In this Gree unit, a new circuit has been installed. As you can see, I have brought a completely fresh PCB. Once the electrical connection was made, the control board powered on, as confirmed by the LED status indicator. D105 is blinking here. Now I will supply power to it again. At the moment, the display is in the off position, so I will turn it on. So, it has started working at a temperature of 17 degrees. The fan has started running. At the same time, the compressor gave a sudden jerk, tried to start and then stopped. You can see, fan is running very fast, but the compressor is just jerking, trying to start. Now it gave another jerk again, but still did not fully start. Meanwhile, the outdoor fan is running at full speed, and now that has also turned off. Let's leave it for a while because it just made a starting attempt, and then the compressor shut down again. Now the display is showing an H5 error, so in the very first attempt, it has already detected that the compressor is not starting. Now we need to find out what exactly is causing the problem. This new PCB could be faulty, because H5 can also indicate a PCB issue. It could be a fault in the outdoor PCB as well, and the compressor itself might also be defective. For example, it could be jammed or damaged for some reason. First, what I did is remove the cover on top, where U, V, and W are labeled. Then I confirmed this section. Now, how will I identify which wire is U, V, and W? For that, I followed the PCB traces to determine each wire correctly. The red wire is W, the yellow wire is V, and the blue wire is U. Now, if I follow the pattern printed on the cover, you can see that W is positioned at the bottom. This means the pin on the right side here corresponds to W. So according to the PCB, the red wire is connected to W. In the same way, the blue wire U is also connected in its correct position. And the yellow wire is V, which is also connected to the V position. So now it is confirmed that all the wiring connections are absolutely correct. There is no issue in the wiring. Now, using a multimeter, we will check the compressor windings. We will set the multimeter to ohms mode and measure the resistance between any two wires first. So first, I placed one probe on the blue wire and the second probe on the red wire. At this point, the reading is about 9 ohms. Now you should note this value because when you check the other windings, the readings should be similar. Here, another reading is around 1 ohm to 1.1 ohms. A small difference like this is acceptable and not a big issue. Now we will also check the resistance between the remaining pair of wires. So this means the winding resistance is approximately correct. There is no issue in the windings. Now what we will do is check it further. As you can see, this is the compressor and it has a copper line, discharge pipe. When I check between the winding terminals and the compressor body, it should not show any resistance, no continuity to ground. You can see it is not showing anything. Even if I change the probe position, still no reading is coming. Normally, if there was a short, it would appear on all points, but here nothing is showing. This means the compressor windings are completely okay, with no grounding or internal fault. However, the compressor is still just giving a jerk and then shutting off. And it stopped again, so it's possible that the compressor is internally stuck. There can be two reasons for this. Either the compressor itself is faulty, or the PCB is not able to start it properly. If the PCB is faulty, it can also cause this problem. Now I have connected an analyzer here, and we will check through the analyzer whether the PCB is providing the correct voltage or not. So I'll turn the power on. The fan has started. Now watch the analyzer very carefully. You can see that all the IGBTs turned on and then immediately turned off. Furthermore, an H5 error code has started to appear. We have now verified that the new PCB is fully functional. My assessment is that the compressor is either seized or has an underlying technical issue. Let's run one final test. I've got a spare compressor on hand. It's a bit smaller and slightly different from the unit's original compressor, but since it's a universal type, the chances of it working with this setup are very high. The power supply is now connected, so let's power up the unit. I've initiated the start sequence with the remote. The system is on, and the fan has immediately engaged. Following a brief delay after the fan starts, the control board signals the compressor to run. And there we have it. After a few starting surges, the compressor has successfully powered on. We can observe that the suction side is operating correctly, and the discharge side is successfully generating the required pressure. This proves that the compressor inside the unit is stuck.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.